Good afternoon, everyone. I appreciate being here. This is a topic that we've been dealing with for a long time along the AT, and personally I've been involved in backcountry management and wilderness and long-distance hiking trail management for about 20 years. I started as a seasonal backcountry ranger in the White Mountain National Forest with the Appalachian Mountain Club. Went to a coordinator role and then a supervisor and manager role, and most recently came into a director position. So my role with human waste management went from a hands-on operator as a seasonal employee to coordinating a whole system of backcountry toilets, composters, to a manager to figuring out, well, how do we budget for this and meet our annual objectives and everything else. And now as a director to bring together different research that's been done in other areas like all of you are doing, and coordinated with our trail clubs that maintain various sections of the AT. So really kind of coming at it from a full spectrum here. So we're primarily going to be discussing some systems that are currently on the Appalachian Trail. And before we go into the discussion about the composters, I just wanted to give you a little bit about the AT itself. So the trail's over 2,100 miles long. It spans through 14 states. And it is a unit of the National Park System. Not everybody realizes that. As a National Scenic Trail, the 1968 Scenic Trails Act designated the AT as the first National Scenic Trail. There's 8 or 9 others in the system now. The AT is for foot travel only, and that's human foot travel, so no pack stock is allowed on the Appalachian Trail, except for one section through Great Smoky Mountain National Park. About 70 miles of the AT go through the Great Smokies, and that's due to historical use. Pack stock was already using that section of trail prior to the AT being laid out across that trail system. Approximately 2 million visitors per year across its whole length. Some areas obviously see more use than others, and we'll talk about that in a little bit here. And it's maintained by a unique system known as the Cooperative Management System. So the ultimate jurisdiction is the National Park Service through the Appalachian Trail Park Office, which is based in Harpers Ferry, West Virginia, through a park manager, park superintendent. But a significant amount of the responsibility for the maintenance and protection and management of the AT is delegated to the Appalachian Trail Conservancy. That's the organization I work with as the New England Regional Director. And we then, in turn, delegate a fair amount of the maintenance out to exactly 30 trail clubs that maintain sections between Georgia and Maine. And part of the responsibility of our maintainers is maintaining 270 designated overnight sites, and all of them have a toilet. So they range from pit toilets to moldering toilets to batch bin toilets to a few have Clivus Multrum systems too. One thing that distinguishes the AT from the other National Scenic Trails is that final bullet. If you look at the Continental Divide Trail, the Pacific Crest Trail, and some of the others, they don't necessarily have this continuous system of designated overnight sites. The CDT and PCT are much more about dispersed use, so waste management is primarily through cat holing. We'll take a look at some quick maps here that show the trail's route. So there's the 14 states. It starts at Springer Mountain in Georgia. I'm just going to move this a little bit here, folks. Springer Mountain in Georgia and runs the 2,100 miles to Mount Katahdin in Maine. And the section that I'm responsible for maintaining, managing, and protecting is from the New York-Connecticut line to Mount Katahdin. It's about 700 miles of the trail. The trail, not only being a unit of the National Park System, also runs through 6 other units. We mentioned Great Smoky Mountain National Park, the Blue Ridge Parkway, Shenandoah National Park, the C&O Canal National Historical Park, Harpers Ferry National Historical Park, and Delaware Water Gap National Recreation Area. Incidentally, in the discussion earlier on NPS composting and toilet systems and some of the health statistics and all, you might have noted that chart. Well, some of the 2 highest use areas are on that chart were Great Smoky Mountains and Delaware Water Gap. Matter of fact, does anybody know the most visited unit in the National Park System? That's right, over 10 million visitors a year visit that park. The AT runs right through the center of it, 10 million. The trail does run through 8 national forests. Matter of fact, about half of the 2,100 miles are on national forest land. And here's a little bit on the history of composting on the AT. They were first developed by the Appalachian Mountain Club in the White Mountains, primarily in response to a sharp increase in visitation. Many land managers have been this for a while and know the sort of rise in popularity of outdoor recreation in the late 60s and 70s and what the kind of pressure that put on protected areas. And we've really run the whole gamut. We've done pit toilets, we've experimented with some earlier Clivus, the Soul Trans system, and airlifting through haul-out buckets, and we'll look at some more of that in a little bit. The earlier systems we developed had both urine and feces in the same container, and you'll see some photos here in a little bit what that was all about. But you've heard discussion already about the challenge of absorbing liquid and the amount of weight that urine contributes to the process, to the pile. So we developed a system that separates out the liquid in the mid-1990s and have, well, we're actually up to 14 now of that, and there's the Green Mountain National Forest, the Green Mountain Club has 4 or 5. There's one in Maine and a couple in the Smokies, so there's about 20 or so total. One of the challenges we have in the northern part of the trail, this is actually in Maine, is extremely thin soil. The northern part of New England was glaciated as recently as 18,000 years ago. Sounds like a long time in terms of our lives, but it's not very long in terms of dramatic altering the landscape and soil buildup. So this is actually the treadway of the AT across the Mahoosic Range, and you can get a sense of how thin the soil is underneath, with the bedrock underneath. We use the analogy that it's essentially like carpet over a granite dome. If you were a giant, you could just pick up this whole layer of carpet with the trees on it and everything, and there'd just be these granite domes underneath. So this is one of the challenges with pit toilets, is finding a place where you can dig without hitting impenetrable rock. So we call it the beyond the bin. It's not quite accurately named because we still use the bin, but it's known as the BTB. And these are the necessary conditions for effective composting. We've heard some of this already this morning. Oxygen through aeration, appropriate amount of heat in the pile. We'll look at that in a little bit. Absorption, the dedicated operator, key component, and time. So all of these together, when we look at these piles, are what contribute to effective composting. And our ally in this process, one thing we're endowed with in the Northeast is hardwood trees. So we use hardwood bark. I have a little sample here. This is the fresh stuff, not what's going to come out on the other end, which you'll see photos of. And we get that through a local mill, and it's through their debarking operation as they're processing logs for furniture or home building and what have you. So it's delivered to a base facility in a large dump truck, and then we actually bag it into these grain bags. Into about 50 pounds per bag. Each compost run takes about 12 of these, so about 600 pounds. And depending on the visitation of a site, we'll use between 16 and 40 bags per site per season. So lower use, less bark, higher use, more bark. There's a correlation between visitation and bark, as you would imagine. So how do you get it in? Well, in some locations, we pack it in. We have one site that's in designated wilderness, so we can't airlift it in. It's carried in by human beings about 3 miles in from, we basically airlift to the perimeter of the designated wilderness area and then pack it from there because the wilderness boundary is well interior and backcountry. But that is, and one other place we do airlift to because, pack in instead of airlift because of the logistics of airlifting. But the majority is actually airlifted in. And we hire a private contractor in New Hampshire, and we use the Bell Jet Ranger. It's a ship that probably some of you are familiar using for backcountry airlift operations. And the bark is hanging from a cable. This photo doesn't show it, but it's hanging down. And we actually put it on a mat, and we developed a system a few years ago that was kind of slick. We can fit 16 of these 50-pound bags on one of these mats, and we lay it flat, and the mat has 4 lines on it, one at each corner. 2 of them are attached to a fixed ring in the center, and then the other 2 are on single rings. Hanging from the cable is a hook with electric release, and on the side of that is a fixed hook. So the 2 single rings go the electric release, the other ring that ties 2 together goes on the fixed hook. So the pilot comes in, he drops the load down, and all these bags are stacked on here, hits the electric release, so these 2 lines drop off, powers up, and the ship has enough power to lift the mat out, and the bark bags stay behind. So we don't have to have any personnel on site or leave any airlift material, any rigging at that location. Part of the effective composting system is visitor education and compliance. So one of the things that we developed when we had the old system before we separated was encouraging visitors not to urinate in the outhouse, to break that societal habit of association as a bathroom, a place to do both, because urine is our nemesis. It cools the pile down. We have to use a lot more bark to absorb, creates the odor. It's the fecal urine ammonia mix that creates the foul odor. One thing we've learned is a clean and at least I wouldn't say pleasant smelling outhouse, but not inoffensive smelling outhouse encourages compliance. So we have that sign right on the door. And on the inside of the outhouse is another sign asking visitors to flush with a handful of this bark. And we leave a bag, you can barely see it in this slide on the left, of this bag that when people are done, they throw a handful down. Okay, we're next going to look into the actual operation. So there's 3 components that are necessary. That stainless steel bin on the left is actually from the old systems. We used to collect urine and feces directly in that, but it turns out now it's an ideal mixing container because it's about the right size and it's very durable. It's made of stainless. We use these rubber gloves available from Gempler's, and they're made for dealing with caustic chemicals. They're very durable and impervious to any transfer of liquid. There should be eye protection and other, clothing. Some people wear like a Tyvek apron or something like that. And then a pitchfork and a D-handled shovel. So this is reality. Underneath the outhouse is a product made by Rubbermaid. This is a livestock feeding trough that we've adapted to collect waste. And it has a false bottom on it when we look at it a little bit, but we get feces, toilet paper, and the bark, hopefully, is all that ends up in there. In the back a slide or 2, you saw the slide about flushing with bark. We also have information on there and leave no trace, so people are not, throwing their trash and everything else in the outhouse. So the first step in all this is you do what we call homogenizing. So you take the pitchfork and you work the whole pile so that you get the same consistency throughout, so that everything is sort of folded together. And after you do that, it looks like this. I've trained hundreds of seasonal employees in the management of these systems and the operation of them. And as we hire people and we tell them this is part of their job, initially there's some hesitation and squeamishness about it, as you might imagine. But the universal response after people are trained and learned how to do this properly, the quote always is, "It's not as bad as I thought it would be." So people's anxiety that haven't done this before build up. And we tried to make it as operator friendly as possible between the bark, the proper protection, and getting the liquid out. The crux of making this system work is to make sure that you judiciously break up the solid clumps, and the D-handle shovel is best for that. We do have another tool that's made for chipping ice, actually. It's about 4 inches wide. It's kind of a chiseled shape blade on it, and you just chomp away at the solids and get those broken down to smaller particles. The mixing ratio is about 3 to 1, so it's 3 shovelfuls of bark to 1 load of waste. And that creates the ideal ratio for carbon and nitrogen in order to create an environment which is going to be colonized by the types of bacteria and fungi that we want to have in the pile and create it inhospitable for the pathogens and parasites and other undesirables that we don't want to have in the pile. And I'll have more on that a little bit here. So this right here takes a lot of time. An operator, when this collector here is full, it's about 400 visitors worth of use, approximately, depending how much bark people throw down. Some people throw too much and it fills up faster. So we have to make sure that you break up the clumps sufficiently and move things along. And this is just looking at what that process is like. And when you finally get through it, this is what you see at the bottom. And this strainer plate is custom made. It fits in the inside of this tub. And it's a plate that is about 1/4 inch thick, and a series of holes are drilled in it. So the solids stay on top and the liquids drop through. They drop through into this lower chamber. This system's been in use for a while, so there's a little bit of a slurry that can build up in the bottom, which can be cleaned out every couple of years. It's only about 1 inch thick. Because there's a drain on the side, you can see here. That hole was already there on the, through Rubbermaid, and we just adapted a simple plumbing scheme to fit that. The drain pipe comes out with a shutoff valve. That just shows more of it. And eventually goes into this filter medium, which is a buried 55-gallon shipping barrel. And this is with the lid off. So there's anthracite coal in the top 2/3 of the barrel, a geotextile membrane on top of septic stone at the bottom, and there's holes drilled in the bottom of the barrel. So you get about a pint or so per visitor that comes through that drainage system. It hits this splash stone, which is placed on top of the anthracite so that you don't just super saturate the center of the filter medium, disperses out, and then percolates down through at a very slow rate. We've had this system tested, and our standards meet the standards for Class B backcountry water. In some places, we've met Class A, so very effective. Where you're too close to water or you can't dig a deep enough hole, like that ledge photo I showed you, you work with the grade so that you have the outhouse, the filter medium, and then the lowest point in the system would be this collection barrel. So it's not actually leaching out, it's just going to collect in the barrel, and then that's either pumped or bailed out, carried away, and then dispersed out. This is just showing the system ready to go back in, a little bit of bark in the bottom. That's in the back of the outhouse. So what happens from there? Well, it goes inside these bins, and this is a little better shot. So this is what we consider to be a full bin. This is about 50 to 55 gallons of human waste mixed with bark with that 3-to-1 ratio. And it's going to sit in this bin for 4 to 8 weeks, depending on the location. We're monitoring temperature. That's a long probe garden composting thermometer in the center there. And what we're doing, as I mentioned earlier, is creating an environment where you have thermophilic bacteria colonizing the pile so that they create an environment that is inhospitable to thermophobic bacteria. This is a chart that shows the profile of a pile going through what we call a run. And typically you'll see for the desired temperature range, it's from 120 to as high as 155 Fahrenheit, maybe 160 if you get a really good mix going. And you monitor that temperature, and as the temperature goes down, then it's time to mix. So you either mix internally in the bin, but the most effective way is to actually transfer the entire pile into a second bin, just like you might want to do on a garden compost to really get that oxygen back in there, break up the material that's become compressed and consolidated, and importantly, take the center out and bring the corners and the bottom of the pile up. So you're basically turning the pile inside out. The way these systems work is they're self-insulating. The center of the pile is always going to be hottest, and the corners less so. So by folding it all in, you make sure that every part of the entire pile is exposed to that core. The third step in the process is to put it out on drying screens. And what this does is get the last of the moisture to evaporate off. And from there, we actually sift it. So we take the pitchfork, usually, and you sift the material over this number 18 by ½ inch, either galvanized or stainless expanded metal. It's just about the right size so that the coarse bark material stays on top, and the humus that we've created, the end product, falls through. So this is what we actually produce in the end. You can see it's predominantly small pieces of bark, and as a colleague of mine says, an inoffensive earth-like substance. So it does resemble soil with a few chunks of small residual bark in it. One of the advantages to the dispersal and sifting is we're dispersing lighter, finer material, but after we sift, we leave the bark on top of the screens for a few more weeks maybe, preferably with sunlight, and they dry out that much more, and we can reuse that bark back into the front end of the system. So we're not dispersing all of the bark with every run. It's folded back in and run through until it breaks down to this smaller particle level. I'm going to run you through quick here on construction and then some pros and cons of these systems. Roger mentioned about 10 years ago, through a collaborative effort, we produced the Backcountry Sanitation Manual. Anybody here ever reference that? It's online? Okay, a few of you, good. There is full plans for these systems in there, and I'll show you a slide of how to access that in a little bit. But basically, you build about a 6x6 is a large enough footing so that it's going to have runners supporting it to the exterior. Just showing another phase of it. And then we spike together 6x6s 5 or 6 levels high to support a standard 4x4 foot outhouse. And that dimension's just right to fit that Rubbermaid tub also. And then a standard set of stairs up the front. Okay, let's look at some pros and cons of these systems in comparison to others. So on the plus side, we test about every 5 years, so we've got 20 years of data at this point. We send it down to a lab, one of the state labs, to check for coliform. And I mentioned time at the beginning, and that's a key piece. So the longer that the material is either in the bins or the screens, the higher your level of pathogen mortality will be. But even in the systems where we have to move forward because of, we call it pressure from the collector, you know, like you got to move your bins forward to the screens because the collector is ready to empty again. Even in those systems where we're dispersing 6 to 8 weeks later, we're still seeing a 97 to 98% pathogen mortality. I mentioned the inoffensive earth-like substance. The outhouse odor is musty at best, really no odor at all. Suitable for high-use areas because you can move a fairly substantial amount of waste in one season on site. The visitor education and stewardship opportunity we've seen in some of the presentations here, this concept of away, like waste is taken away. Well, here it's treated on site. And we consider that a big plus of this system for the visitor to understand that their waste does not disappear, that there's somebody dealing with it and dealing with it laboriously. And it's a relatively low-tech system. There's no moving parts, no fans to break or solar panels to get vandalized or anything like that. It does require, that maintenance from the operation standpoint, but the parts part of it are really pretty simple. The liquid aspect is just by gravity, so that's pretty good. The negative sign, the external mixing agent, the bulk, the mulch that's brought in, we consider a negative because you have to get that into the backcountry. It's kind of the inverse of some of the other systems where you're not actually taking waste out, you're bringing something in so you can treat it on site. So that has an expense related to it and labor. The dedicated personnel, we've heard that a couple times now, but I think one of the values of this system in terms of keeping people invested in it is that end product. They see the benefit. They see the value of what they're doing. It isn't, again, just taken away. Even the operator has the satisfaction of taking, this large vat of human waste and turning it essentially into soil. So there's a hook there that people buy into. There is a modern amount of infrastructure. There's, you have to purchase the Rubbermaid tub and put the plate in and make the bins and all that. But they're a one-time upfront. If you use good materials that'll last a long time, you could go decades without replacing it. And then relatedly, the initial upfront cost is in the several $1,000s range, particularly when you factor in the airlift. I mentioned the manual, AppalachianTrail.org. If you go on there, there's a section on the homepage called Trail Management, and there's, I think, management resources or something like that. That will be the link, and that's my email there if you want to get any more info. The question is, we use bark. Would wood chips do the job? The wood chips do work. If you can get hardwood, that's preferred. The porosity of bark, the actual ability to absorb, is actually higher than a wood chip. If you want to look at this, you'll see that it's relatively coarse, so it provides not only absorption, but lends that porosity to the pile that allows oxygen to come in. If you use chips, they tend to compact more into the pile, and you don't get the same level of absorption. But if that's all you have locally, then you just may have to work with it more. Right. Right. Yeah, I didn't quite include that part of the operation. So after that sifting on the screens that we showed you, and that inoffensive earth-like substance that falls to beneath the screen, we take a shovel and load it into buckets or back into the feed bags and take them away from the campsite, water sources, wherever people are, and you dig it into a wide broadcast to span it out. As far as regulations go, we've been able to do it because we've had some support from the National Forest that have viewed that as favorable over pit toilets. And because we have these test results of what we're actually dispersing from a coliform count and pathogen destruction, there are some, you're going to see in the next presentation, there are a couple state agencies that, one in Pennsylvania, that actually ban pit toilets too, and really don't want feces in the ground at all. So it varies a bit by jurisdiction, but both the Green Mountain National Forest and the White Mountain National Forest have signed off on us dispersing the end product.
On the bark, do you have to do any pre-processing with that to get it to the right size? What happens there?
We don't actually have to do any processing, but we have to make sure that the mills understand the coarseness that we need. There's a cutter head that they have on their debarker, and we had one supplier for a while that was consistent in what they gave us, but unfortunately they went out of business. The wood products industry in New England is fairly volatile right now, but we have a good source now, and once we let them know what size we need, then they install that chipper head on their machine, and they're consistent in what they send us.
So what size is that actually that you're going for?
Yeah, it's a sample right here. Okay. I can just give it to you.
And also, have you ever checked the temperature? What's your max temperature you've gotten in your bins then?
Well, it's sort of bragging rights for a composter, like how hot their piles get. We have all these seasonal staff, and they get together on days off or whatever, and, I got 158, so the hottest you'll see is peaking out in the high 150s, maybe 160. But anything from 135 on up, we consider to be effective. That's sufficiently hot to kill off.
Right, and according to Jamie Bartram at WHO, who's also now at the University of North Carolina, who wrote the guidelines for the WHO, 50 degrees centigrade, which is 122 Fahrenheit, for 1 week is the WHO standards for compost. So yeah, you're well above that, which is really good.
Yeah, thanks for that. And we've always thought as 120 is the absolute low, but we encourage our staff to shoot for 130 and above. Yeah. And that's through proper mixing to make sure that you don't have disproportionate feces to bark, and the mixing, re-oxygenating and making sure that you're taking. We basically plot 9 points in the pile with the probe, to make we're checking the corners and the center and see where that gradient's starting to drop off. Then it's time to reinvigorate the pile.
So it seems like we got a couple different objectives that are possible in composting. So one is for the user, because it seems like it generally smells better than the pit toilet. The other is for the nutrients. Let's keep the nutrients out of the environment. The other one being pathogen. Let's make sure we're not contaminating waterways with pathogens. And then the final one being cost, perhaps, because it could end up being cheaper than a helicopter flyout. So just wondering if you could put those in order of how it relates to your design of the system, both in terms of the technology and the labor hours.
Sure. Well, you hit a number of the key points why we're committed to this. We initially went to full composting through that system in the White Mountains, primarily as a conservation organization. We're questioning pit toilets, the appropriateness of that, particularly with the shallow soil and high visitation and water source protection, et cetera. So that was an initial motivator, plus the airlift expense it is less expensive. I've done all the math. It's cheaper to fly bark in to fly waste out. Okay, so there's that simple answer to that maybe. But in terms of priorities from a management standpoint, right now it is related to the airlift, and that's really where this liquid separator came in. One number I didn't give you or I didn't actually mention too much about it, but the sites where these are primarily used vary from about 500 visitors per season, and that's beginning of June to the end of September. That's when we have accurate numbers for. They are used year-round. So some of them year-round will see a low of maybe 500 to over 4,000 visitors. And before we had the liquid separator, the highest use site, it's Garfield Ridge Campsite, has the distinction of being the most popular campsite in the entire Appalachian Trail. It's right in the heart of the White Mountains. Anyway, that site, the last year before we had the separator, and we had to fly in 60 of these 50-pound bags, 60. So 3,000 pounds of bark went in. When we put the separator in the next year, we only had to fly 40 in. So that was a motivator right there, just to bring that expense down. Right now, the contracting time is $1,500 per hour for the helicopter. It's $25 a minute. So anytime we can reduce the number of loads going in, we just saving money. Plus the impact, basically that broke out for Garfield. Instead of doing 3 loads in, we were flying 2. So there's a little less impact on the landscape and the visitors.
Okay, awesome. Relating to that, what happens with the urine? You said that gets hauled out or shipped out, or?
No, the urine, for the systems that we can drain right out of the bottom of the barrel, that it just percolates in the soil. You have to remember the volume is relatively light. And this is where you have to work with your approval agencies about this, because many septic engineers are used to dealing with high volumes of liquid through flush systems. So this is just a simple gravity system that a small amount is percolating out. So that's just going into the soil. We're either too close to water or confined within the campsite where we can do this, and it goes in that collection barrel. And this is probably the grimmest task of it all, where you have to pump or bail out that liquid. And it's other people's pee that's passed through feces. So that's what you're carrying. That's how we frame it to people. So you put it in these jugs, with good fitting lids, and carry it away from the site, where you then can disperse it in small amounts throughout the forest, similar to the amount that would go through the bottom of that barrel if you could leach it out on site. But it's not hauled out of the backcountry.
How often does barrels?
Yeah, it's again a function of use, but a 55-gallon drum will see about 30 gallons in a season. So we tell the rangers, to do a little bit of work often instead of wait till the thing's full and then have to deal with the whole barrel. So when they go on site to do the maintenance, they'll take 5 gallons and disperse it out.